Today we're going to talk about scatter plots and lines of best fit. And this is just the first part of the lesson. We're going to do some practice in the lesson, and then you're going to gather some data and start some homework, and we will deal with the data in our next class. So you should have your notebook and your pencil out, ready to go. The three things that we have on here is just a discussion as to why we do scatter plots and lines of best fit. We're going to use the main idea of algebra, and one of the main reasons we need to learn it lies in this section. We also have the second one. In algebra, we can find patterns and relationships in data, generalize these patterns, and use the data to make predictions of future events. And the last one, we're going to use prior knowledge of slope and linear equations to predict the future very accurately for the next couple of days. This page should go into your notes. We're going to talk about two things today. The first one is a scatter plot, which is a graph that shows a relationship between two sets of data. And then we're going to learn how to do a line of best fit, which is a line drawn on a scatter plot that is close to most of the data points. Definitely get the part down here in the white. We're going to try and get our line as close to the data as possible, where half of it is above the line and half of it is below the line. So pause the video and get this in your notes before you move on. So let's take a look at our first scatter plot. This scatter plot shows the total fat grams in a restaurant sandwich compared to the calories. Let's answer A, B, and C. How many calories are in a sandwich that contains 17 grams of fat? So I'm going to go along the bottom to about 17, and I'm going to go straight up. Here's that point that I hit. So I go across. There are 400 calories in that sandwich. Letter B then wants to know how many grams of fat are in the sandwich that contains 600 calories. So I'm going to go to 600 calories. I'm going to go across and then straight down. That has 30 grams of fat. Letter C, what tends to happen to the number of calories as the number of grams of fat increases? So we're looking along here. As our fat grams go up, what happens to our calories? So every time they go up, it tends to go up. So the calories also increases. As the fat grams go up, so do the calories. So what about if we wanted to make a prediction? A sandwich has 650 calories, so that's this. Based on the scatter plot in example 1, which is the one we have here, how many grams of fat would you expect the sandwich to have? So this is where I want it to go. I would say it's going to be somewhere in between 30 and 35 grams of fat. We make a prediction using our scatter plot. So I want all of this into your notes as well. Pause the video, and if you can even draw the pictures, that would be great. As x increases, y increases. We have a line that has a positive slope. That's a positive relationship. As x increases, y decreases. That's a negative slope or a negative relationship. And then we have no relationship. The points are all over the place. They don't go together at all. Pause the video and get this into your notebooks. So now that we know what the relationships looks like, let's go ahead and identify some. So we want to know if the data shows a positive, a negative, or no relationship. So we have television size compared to the price. So as our television size increases, what happens to the price? Well, it goes up, so it is a positive relationship. How about age and the number of pets owned? So as a person age goes up, look at our dots all over the place. There is no relationship. Pause the video and you try a couple, see if you can figure it out. I would say the relationship between study time and test scores is positive. And between age in years and the value of a car, that's what this is, value of a card that decreases, or it is negative, not decreases, negative. So now let's put everything together for us. So it says work with a partner. We're going to do these all together. You've been working on a science project for 8 months. Each month you have measured the length of a baby alligator. The table shows your measurements. So what we're going to do is right here. We're going to start by graphing the data. Then we're going to draw a straight line that best approximates the points. That's where we're going to get half the data above the line and half the data below the line. We're going to use what we know with point slope form to write an equation for the line that we drew. And then we're going to use that equation to predict baby alligator's length next September. So let's go ahead and start with letter A. We're going to graph the data in the table. We have the months down here on the bottom, and we'll have the lengths on the side. So at 0 months, he was 22 inches. At 1 month, it was 22 and a half. 2 months, it was 23 and a half. 3 months, it's 25. He jumped up to 25. At 4 months, he was 26. At 5 months, 27 and a half, so another big jump. And at 6 months, 28 and a half. So we got A done. We graphed our data. Now we're going to draw a straight line. And I want to go with about half of the data below the line and half the data above the line. Now this is going to be tricky just because it's all fairly close. And I'm not going to draw a perfectly straight line. But if we draw a line somewhere in here, there, sorry, a little bit better. I'm going to use this first point and the last point. So I'm going to use 0.22 and 6.28 as kind of my points. And you should always try to include some of the data points on your line. It will make it easier to figure out the slope and that stuff. So now we're done with letter B where we drew our straight line to the best of our ability. So now let's do letter C where we're going to write the equation. So we're going to start with slope. Remember, slope is change of y over change of x. So my y goes from 22 up to 28 and a half, and that is 6 and a half. Over my change in x, I'm going from 0 up to 6, so that's a change of 6. And when I divide this, I get 1.08. I'm going to round it to 1.1. I'm going to round it to the nearest tenth. So there's my slope. So now we're going to put it into slope-intercept form, or point-slope form, I'm sorry. Remember, y minus y1 equals m times x minus x1. So we're going to use the first one just because I like using 0 if I can. So y minus our y, which is 22. Our m is 1.1 times x minus 0. So we get y minus 22 equals 1.1x, and 1.1 times 0 is 0. I'm going to add 22 to both sides, so I get an equation of y equals 1.1x plus 22. So then, use the equation. We got letter C, now we have our equation. Predict the baby alligator's length next September. So that would be 12 months from now. So we would do 1.1 times 12, which gives us 13.2, plus 22, which means next September, the baby alligator would be about 35.2 inches. So let's see how we did. Here's our equation. We used the same points that they did, the first one and the last one, and we came up with the same answer. So let's do another one. This time we're going to be working with bats. You're asked to predict the number of bats that will be living in an abandoned mine in 3 years. So first we have our data on our graph. we're going to follow the same steps. We're going to graph it, draw our line of best fit, write an equation, and then use it to make a prediction. So let's go ahead and start by plotting the points. So 0, we're at 327. So we have to do a little bit better approximation because we have a little bit more space in between our lines. 1, 306, so that would be just under the 310. 2, we're at 299, so 299 would be right above the 290. 270, that one's easy because it's right on a point. That might be a good place to draw our line of best fit through. 4, we have 254. So that would go right above the 250. 5, we have 232, right above that one. 6, 215, so maybe up a little bit. And 197 at 7, so that looks about right there. And on some of these, you just have to do your best job. So we graphed it. So now let's draw our line of best fit. And I'm, again, doing the best I can. I think I'm going to use our first point and then that third point. So I'm going to go through here, and I'm just going to keep on going. And it looks pretty darn close. It doesn't have to be an exact because we are using an approximation. So we drew our line of best fit. So I used that first line, and I used the 3, 270. So again, start out with our slope, change in y over change in x, something that we've done before. So change in y, 327 minus 270, I believe that's 57. And from 0 to 3, that's 3. And if I divide it, I get 19. So there's going to be my slope. That's going to be our m. So now let's go ahead and put it into point slope form. So y minus y1 equals m times x minus x1. So y minus, and again, I'm going to use the 0 just because that is nice and easy, minus 327. Our slope is 19 times x minus 0. So y minus 327 on this side. 19 times x is 19x. 19 times 0 is 0. And then I'm going to add 327 to both sides. So we get y equals 19x plus 327. There's our equation. So now, in 3 years from this year, so we're going to add 3 to that 7, that would be 10. So 19 times 10 is 190, but I realized I forgot something. Let's go back to our slope. I'm going from 327 down to 217, so this should be a negative number. So our equation should be a negative 19 because we're going down. So negative 19 times 10 is negative 190 plus 327. So now if I put that into my calculator, I get 137 bats after 3 years, in 3 more years. So taking a look, we definitely have it going down. There is no answers here, but I can tell you that we did it correctly. So now you're going to gather data today and start homework so that we can graph it and get a line and best fit for next time. So today in class, what you're going to do is you're going to find your height in inches, and you're going to see how far you can jump in inches. We've got rulers for you to measure your height, and you can help each other out. You're going to stand in one place and then jump forward as far as you can go. And you just land one jump, no hops. Once you land, have somebody measure how far that is in inches. And then there's a Google form in Schoology where you are going to enter your data. And then you're going to start working on your homework, which I'll talk about in a minute. And next class, we will put it together. Once you're done getting your jumping data and your height data, you're going to start the scatter plot worksheet. And it's quite long and it's got a few problems, but it is your practice. It is not due next class. We will talk about it more, and there's some problems that I'm sure you're going to have questions on, but I want you to at least get started. If you have questions, send me a message, and hopefully I will see you next time.